Today we are going to be doing double and compound angle identities. So before we get started, I'd like to give you a few tips. The first thing you need to do is always split your left hand side and your right hand side. The second thing is you work with one side at a time. Sometimes the right hand side can be simplified as well as the left hand side, so you simplify both sides. The third tip is oftentimes when we are busy with the sum, we don't know what to change cos 2x to, purely because cos 2x has three identities. So what we do is we write it in pencil until we know what to change it to. The fourth step is that we always change tan theta into sine theta over cos theta, and then the fifth tip is that your sine squared theta plus cos squared theta is 1. You've done that in grade 11. Those are our grade 11 identities. So these are our double angle identities, where sine 2x is equal to 2 sine x cos x, and cos of 2x is equal to cos squared x minus sine squared x. It's also equal to 2 cos squared x minus 1, and it's also equal to 1 minus 2 sine squared x. So let's look at our first example. 1 plus sine 2x over cos of 2x is equal to cos x plus sine x over cos x minus sine x. So here we can see that we can simplify the left hand side. So what we are going to do is we are going to look at what can be simplified. And if we look at the sine 2x, we can see that that can be simplified to sine x, 2 sine x, cos x over cos 2x. So do you remember I said right at the beginning, oftentimes we don't know what to change the cos 2x to. So what we do is we write it in pencil until we get a clear understanding of what it can be changed to. So now when we move on to the next line, we know that sine squared x plus cos squared x is 1. So we replace that identity, and that leaves 2 sine x cos x, and we know that this gives us sine squared x plus 2 sine x cos x plus cos squared x. All we've done is rewrite it, but you can see that I've changed the identity now. Why have I changed the identity? Because with experience, you have the foresight to see that when we simplify this line, when you simplify that, it will be a trinomial. Okay, write that down for me, please. Okay, so you guys remember what I said before, that the numerator looks like it could be factorized, look like it could be a trinomial, and factorized into sine x plus cos x, sine x plus cos x. We changed cos 2x into cos squared x minus sine squared x. And that simplifies, that's the difference of two squares, and it simplifies into cos x minus sine x, cos x plus sine x. What do we see? We see that the sine x plus cos x and cos x plus sine x, they cancel each other out. They are exactly the same, even though they are written in a different order. So what does that leave us with? It leaves us with sine x plus cos x over cos x minus sine x, which is equal to our right hand side. Let's look at example 2. We've got sine x minus sine of 2x divided by 1 minus cos x plus cos of 2x is equal to negative tan x. Okay, so let's work with the left hand side. We know that sine 2x needs to be changed to 2 sine x cos x. So that would read sine x minus 2 sine x cos x, because it's an identity. And then we have 1 minus cos x plus cos of 2x. As I said before, we haven't decided what to change the cos 2x to yet, so we can write that in pencil. Okay, we can always change it afterwards. And what do we have? If we look at our numerator, you'll see that sine x is a common factor, and we are left with 1 minus 2x. What does that give us? It gives us a clue as to what we can change cos 2x to, because you should be able to see that it looks something like this. Not quite, but it could be changed into something. like that. So what do we have? We've got 1 minus cos x plus 2 cos squared x minus 1. And if you look at this, we'll see that the 1 cancels the 1. That leaves us with 0, and our denominator then will read minus cos x plus 2 cos squared x. Okay, the numerator won't change yet. So that leaves us with a numerator of sin x times 1 minus 2 cos x, and as a denominator we've got negative cos x plus 2 cos squared x. You take out your common factor out of the denominator, which is negative cos x, and we are also left with 1 minus 2 cos x. This is where we can cancel, and we are left with negative sin x over cos x, which is equal to negative tan x, and that is the same as your right hand side. So you've actually proven the identity.